Hello friends, welcome to our channel. Today we shall discuss on the radius of curvature in case of pedal curve. So in order to derive the equation for radius of curvature in pedal curve, so let us consider the line. So this is the x-axis and this is the y-axis. So let us consider it as the origin to be O, and the angle which is made with respect to these two lines will be theta. So let us draw a line. So then after that, so the angle made with this is phi, and this we have taken it as the point P. So now let us draw a curve or a tangent at the point P. So therefore the angle which is made with respect to, since both are on the same side, the angle made by both will be phi itself. And then now we shall extend the line from the origin O to the point N. So now let us take it as the point N, and the line made that is the ON. The ON can be taken as the P. We can define the ON as the P, and then so as we know that the exterior angle is taken as the psi. So by observing this triangle, you can see that it is in the 90 degree. So that will be, so the angle made will be 90 degree. So that is, so this the line ON is taken as the point P, and the OP is taken as the R, where R is the radius vector. So now we shall define everything. So initially let OP is taken as the R. So let OP is equal to R be the radius vector, and phi be the, that is phi is the angle which is made by the radius vector. So phi be the, and phi be the angle made by the radius vector. And we have considered that P is the tangent. So the R is the, we have taken that phi is the angle which is made by the radius vector with the tangent P. So we have considered the tangent P. So with tangent P. So the next thing is, so we have taken the psi. The psi be the exterior angle, or you can say that it is the angle. So let psi be the angle made by the tangent at P with the initial line. That is, we have considered the initial line and we have extended it. So you can also call it as a tangent. So the angle which is made by exterior angle is taken as psi. So then after that, we have constructed a line ON and we have defined it as the point P. So therefore, we need to draw line ON, and the distance between ON is taken as the point P. And then we have from the triangle, so we have considered that ON, and so we have considered that ON is the, so this forms a right angle triangle, that is ON and P. So ONP. So this is one big triangle. So we have from triangle ONP, we can define the sine phi as P divided by R. So from a triangle ONP, you can write it as the sine phi. So sine is nothing but it is the sine phi is taken as the, you can define it as the P divided by R. So where you have considered this as the triangle, and then you can write it as the P divided by R, that is the opposite divided by the hypotenuse. Sine phi is taken as the opposite divided by hypotenuse, which is written as P divided by R. And we know that P is equal to R into sine phi. And this is also the equation for the radius of curvature which we have discussed earlier. So P is equal to R into sine phi, call it as the equation 1. Now we need to differentiate. So that is differentiating 1 with respect to r. So we get, that is, you need to differentiate with respect to r, that is dp upon dr can be written as r into differentiation of sin phi is nothing but cos phi, then into differentiation of phi is nothing but d phi with respect to r will be dr, plus then differentiation of r with respect to r is nothing but 1 into keeping sin phi as it is. So therefore, as we know that, but sin phi is nothing but r into d theta upon ds, and cos phi is equal to cos phi is nothing but it will be dr upon ds. So therefore you can write, so these are standard formulas, that is d phi is taken as r into d theta upon ds. Similarly cos phi will be, you need to consider it as a dr upon ds. So therefore we can write it as, the differentiation of p with respect to r can be written as r into, so just substitute cos phi is equal to dr upon ds, that is r into this remaining is d phi upon dr into cos phi is written as dr upon ds, then plus 1 into sin phi. So 1 into sin phi is nothing but only sin phi. So sin phi is written as r into d theta upon ds. So r into d theta upon ds. So you can, here we can observe that r is common on both the sides. So just take r as the common. So we can write it as d theta upon. So we can write it as, so here you can observe d phi upon dr into dr upon ds. So if you cancel this, remaining will be d phi upon ds. So just if you cancel this both, remaining will be d phi upon ds plus d theta upon ds. So therefore we can write it as r into, so r into, that is in both the side we have d phi upon ds and d theta upon ds. So we can write it as d upon ds into bracket phi plus theta. As d by ds is common on both the sides, we have taken it as d by ds into phi plus theta. And as we know that the exterior angle, that is the phi, exterior angle psi is taken as the two interior angles. So two interior angles are phi plus theta. So they are phi plus theta, and therefore we can write it as dp upon dr. So that is dp upon dr is equal to, it will be r into, so r into, so multiplying, so we can write it as dp upon dr is equal to, it will be d phi upon d psi upon ds, or you can write it as ds upon, that is ds upon d psi can be written as r into, so that is d phi upon ds, or you can write it as ds upon d phi will be r into, it will be dr upon dp. So dr upon dp. So therefore, so thus we can write that, thus the radius of curvature in case of pedal curve can be written as, that is rho is equal to r into dr upon dp. So that is exterior angle phi is equal to, that is psi is equal to phi plus theta we have taken. So as we know that dp upon dr, so we can write it as dp upon dr can be written as r into d psi upon ds. So differentiation of psi with respect to d psi upon ds. So we can write ds upon d phi is equal to, it will be r into dr upon dp. So therefore we can substitute the rho is equal to, that is rho is nothing but it is the radius of curvature. So rho is nothing but the radius of curvature. So we have obtained rho is equal to, it will be r into dr upon d phi. So this is the required equation for the radius of curvature in case of pedal curve. So this is in case of pedal curve. Thank you friends. Subscribe our channel for more updates.